We've been doing factoring and finding various methods to solve quadratic equations. We had some conversations yesterday. Some of y'all were a little confused about exactly why and what we were doing. So remember, what we're doing is we're doing that same solving that we did with these linear equations. We're trying to figure out what x is, except now we're doing it with quadratic functions. And remember, those x's, since we have symmetrical pairs, we could have anywhere from 0 to 2 solutions. We could have 2 solutions if the solutions fall on a y value that has symmetrical pairs. We could have 1 solution if it falls on a y value where the vertex is. We could have no solutions if the thing turns around before it even gets to that value. Okay? So that's what we talked about with our graphing, and that's the reason why we have more solutions. This is why we had to learn all this extra math. Now, here's another thing that we got to talk about, because this is something that you may or may not ever have been exposed to. Hang on. It may not seem much better, but I know the difference. Okay, so when we talk about positive and negative roots, okay, so the first thing that we gotta understand is, up until now, we've only seen half the world. We've been lied to, okay? So if you go to your calculator and you put square root of 16 into your calculator, okay? So I go to the calculator, I square root of 16, it returns 4. Okay, and there was actually a question on your homework that some of you guys tried to do. You tried to solve using the square root method, and you haven't even learned it yet. Okay, so y'all looked at this problem right here on your homework, some of you, and you said, oh, the answer is 10. That's not correct. Okay, and the reason it's not correct is because up until now, your calculator and really you have only ever known about one square root. This square root is called the principal square root. This is called the principal square root, which is the positive root. This is the one that your calculator returns, okay? So the principal square root, the positive root, is the one the calculator returns. Okay? And that's the only one we've known about, right? Because that's the only, if I'm like, what's the square root of 9? Y'all are like, oh, it's 3, okay? So, here's the thing. There's not just one way. So what this is telling me is that I can say 4 times 4 equals 16, okay? So, the square root of 16 equals 4. But there's another way I can get 16. I can do negative 4 times negative 4, because negative 4, whoopsie, that's not right, times negative 4 also gives me 16. So, square root of 16 is also negative 4. So, it's not just one, it's both. Now we have to deal with both roots, because now that we're starting to look at quadratic stuff, we're not just looking at one answer, we're looking at multiple answers. So what this means is the square root of 16 is positive and negative. What am I doing? What's this? Okay, sorry about that. Sorry, that just happened. Okay, positive and negative 4. This symbol means positive and negative, not positive or negative. It's not plus minus. It's positive, negative. So it's telling me that it's both of those things. So it's positive 4 and negative 4. Okay? So here's the punchline. Every square root has a positive and a negative answer. Okay, so we don't just have, so up until now, we've always had more than the principal square root. We just haven't needed to use it. Well, now we do. So this is, again, another little bit of math. We're kind of expanding the math because of the things that we need for our quadratics. Okay, so now that we know that, let's talk about the next method. The next method is called the square root method. Okay, so the square root method right here generally is going to result in 2 solutions. There's a couple of situations where it won't, okay? And this is when you're going to use it. You're going to use it when x squared is equal to a number, so a numeric value. So like this, x squared equals 81, or x squared equals 100. like number 4 on last night's homework. By the way, if you're still working on last night's homework, don't come in here thinking, oh, it's the square root method. I told you to solve by factoring and do what I say. Okay? Now, you can also use it when the middle term is 0. I don't know what that was supposed to be. Okay? So the middle term, b, yeah, b, that's supposed to be a b. I don't know what that was. So b is 0. So, like, there's no b term here, right? Because the coefficient of b is 0. The b is 0, okay? Or if you have a difference of two squares. So if you had, like this one, x squared minus 36 equals 0, you could add 36 to both sides and use the square root method to solve it without even having to factor. And that might actually be faster, okay? So what's that going to look like? It's actually really easy. This is so easy. It's almost always going to result in 2 solutions, okay? So here's what you do. Literally, you take the square root of both sides. The square root of x squared is x. The square root of 81 is 9. But remember, that's my principal root. And we know that every square root has a positive and negative answer. So it's positive and negative 9. Now, I'm going to tell you right now, I don't want to see you writing your answer like this, because this is going to make you think there's a whole brand new sign, the plus minus sign, okay? And that's not a thing. So what I want you to do is, just like when we expand, when we see something squared, I want you to write x equals 9 and x equals negative 9. And I want you to write it like this because I want you to recognize this is 2 different solutions, okay? So when you're writing this, you need to be expanding it to write both of your solutions, okay? So, believe it or not, this guy right here is also, you can use the square root method because there's no b, okay? So, and like, it doesn't quite look like I can use the square root method, but we're going to try anyway, okay? So I need to isolate this and get it by itself. So I'm going to add 10 to both sides. Okay, that gives me 3x squared equals 15. Okay, now I can divide everything by 3. Okay, which gives me x squared equals 5. Okay, well, it's x squared equals a number, so I can take the square root of both sides. And when I put, so the square root of x squared is x, the square root of 5 is that. I'm going to say that that's 2.24. And x is negative 2.24 because, again, I have 2 roots. I have the primary and then I have the negative root. Okay? All right. So this guy. Let's talk about what this means here. This right here, what does this look like? I'm not asking you to use your words and explain and talk, but here's what I'm going to tell you. I'm going to tell you that it looks like this. I see x minus 2 squared, a minus b squared. This is a perfect square trinomial written in factored form. Okay? So if it's a perfect square, guess what I can do? I can take the square root of it. Now, here's the thing. This is where you'll start to get confused. Okay? So this is really important. Okay? I'm going to write x minus 2, because the square root of x minus 2 squared is x minus 2. The square root of 25 is plus and minus 5. Okay, so the question always comes up. Where does the plus and minus go? Do I put a plus and minus over here too? No. I only put the positive and negative roots on the side with the number. So let's write that down, okay? Write that down. So what we're going to write down is the plus minus always goes on the side with, well, let's say not with, let's say on the side of the equal sign opposite the variable. This is kind of a little bit more precise than what I just said, okay? What I said was it goes on the side with the number, and then, of course, invariably somebody says, Yeah, well, there's a number right there. Okay? Whatever side the variable's on, the plus minus goes on the other side. So it goes on the side that just had a number. Okay? So now that I do that, now I have an extra step, okay? Because x minus 2 is 5, and x minus 2 is negative 5. Okay? So what does that mean I got to do? I got to solve this thing. So I add 2 to both sides. I get x equals 7. I add 2 to both sides of this one. I get x equals negative 3. And those are my two solutions. Okay? These are the three most common scenarios you're going to see for the square root method. Now, I remember I told you, in general, we have two solutions. Well, there are some situations where we're going to have other answers. So we might have, this is what we might see when we might have no solution, okay? So I have x squared equals negative 36. Well, if I take the square root of both sides, if I put the square root of negative 36 in my calculator, I get error, non-real answer. I get error, non-real answer. What that means is x is no real solution. Why? Because there is no number times itself that equals a negative. Okay? We cannot multiply something times itself and get a negative answer. The only way we can get a negative answer is multiplying a number times its opposite. Something times its opposite. So 3 times negative 3, 3 times negative 5. The only way I can get a negative number is by multiplying a number times its opposite, or a number times an opposite, and that's not a square root. There is no square root that's going to give me a negative answer. We have a whole number system for this, okay, that you're going to learn, I don't know when, like maybe algebra 2, algebra 2, okay? Okay, so that, if they're asking you, okay, let me just show you something else though. So if instead of x squared equals, if they said there's a difference between this and this. This is no real solution. This is negative 6. This, they're asking me for the negative root. This, they're asking me for the root of a negative. It's different. And if we need to clarify that some more tomorrow, just let me know. But, I mean, they're different things. But this is illegal. No real solution. Now, over here, one solution. The only x equals 0, because remember we talked yesterday about how 0 is neither positive nor negative? We talked about how when we look at the coordinate grid, numbers that are on the axes are not in a quadrant because they don't have, because the 0 doesn't have a sign. So if I have a point at 0, 4, it's not in the first or second quadrant because it's not in a quadrant at all because 0 has no sign. Well, it's the same thing here. I can't say, like if I said x is positive and negative 0, there's no such thing as positive and negative 0. So the only thing is 0. So that's the only situation where I would get one solution. To my knowledge, I could be wrong. It wouldn't be the first time. All right, so that's pretty much it for the square root method. And if you have any questions, make sure you jot them down and bring them tomorrow.